Alright, so let's study for the AP Micro Final. So we have a monopsony labor market. How many workers will the firm choose to hire? Okay, so what you do is you look at where the marginal revenue product curve and the marginal factor cost curve. You look at their intersection point. So, and then wherever they intersect, you go down to the quantity axis down here, and then you bounce it off the supply curve. And so this will be the wage, and this will be the quantity of input. So, or in this case, the quantity of input is workers, and this is wage. So, this is 20. So the answer is B, 20. Next, it says, what wage will they pay in absence of regulation? Well, we just figured that out. We go up to where the marginal factor cost intersects the marginal revenue product curve, and you bounce it off the supply of labor curve, and this is $20. Remember, this is in wage, so the answer is C, $20. Okay, next up it says minimum wage. So let's just kind of clear off some of this stuff off the graph here. So it says a minimum wage. So 25. That means that is basically a price floor is a minimum wage. You cannot pay these people anything less than $25. So the monopsonist wants to pay them right here at $20, but they can't. So they are required to pay at $20 or $25 here. So what they're going to do is we're going to look over here and see where does it intersect the supply curve now. And that is right here at 25 workers. So number 3 is C, 25 workers. And then number 4, it says, what is the maximum wage that could be in this market before it began to increase unemployment? So if we look at the graph over here, once the supply curve and the marginal revenue product curve intersect, this point right here is where the unemployment will start decreasing, or they would have more unemployment. So when we increase this minimum wage here, more people are going to want to be on the job, and they would up to this point. And at this point, they would have to start firing people because they cannot make profit. This is where the revenue is equal to the supply. And at that point, you will not make any more out of your people that you hire. So therefore, this answer is C. All right, let's look at some more of these questions. The factors of production. So the factors of production are things that you input into to create something, whether that's land, labor, capital, anything like that. So we know that answer A is wrong because it's what goes into the system. And so I'm liking B, and wages paid to the workforce. It's not wage, it's not goods and services sold in the market. Factors of production are inputs used to produce goods and services. Land, labor and capital. All right. Because a firm's demand for factors of production is derived from its decision to supply a good in the market, it is called a derived demand. It says it in the question. It is derived from the decision to supply, so it is derived demand. All right, 7. For a competitive profit maximizing firm, the labor demand curve is the same as. So the demand curve. So if you wanted to imagine your little two things, you have your demand and supply, and then you have your marginal factor cost, MFC, which is your supply curve, and you have your marginal revenue product curve, MRP. So the demand curve, this is the marginal revenue product is demand. So if you kind of remember these models, then that can help you know that this answer is B. All right. For a competitive firm that finds it worthwhile to operate rather than shut down, let's see. Output price is equal to the marginal cost. So people will think at the margins, and so if they're going to continue to stay open, then even if the net price is, or the net profit is 0, the price minus the cost is 0, and they will still stay open. So that's true. The wage is equal to the value of the product of labor. That's basically the same thing in the input market. And if they are making as much money as you pay them, then it would be rational to hire them. So B is also true. And wage slash marginal product of labor is equal to P. And so in a perfectly competitive labor market, then price is equal to the wage. So this is also true. All right, so what causes the labor demand curve to shift? So, all right, so the demand curve for labor. So we know that the demand curve for labor is our marginal revenue product. Marginal revenue product. And marginal revenue product is equal to marginal product, MP, times the quantity, or the price of the thing. So this is marginally. We're thinking marginally, so the price of the thing. So the change in productivity, that will change the marginal product. If each person makes more things, then they will be more productive. The marginal product for each person will increase. So this is a true statement. And to shift the curve, the other thing will change, the price. And so whatever the wage is will also affect this. Or, well, whatever the output price is, I'm sorry. Basically, whatever you sell each of the things for, how much each of these workers are doing for you. So this is also true. But changes in wages is not true. That might make more people want to work for you, but that does not change your marginal revenue product. That does not change your marginal product or the price of output. Just because more people or less people want to work for you doesn't mean you make more revenue. Or more revenue marginally. So the answer is C. Alright, if the price of airline tickets falls, what will happen? So, the price of airline tickets falls, then and so the demand curve for flight attendants, that's input, that's labor, that's people working. So we could again look at this formula here. This marginal revenue product is marginal product times price. And so if the price of airline tickets falls, then so will the marginal revenue product. It will shift left. All right. So if Aurora Custom Cabinets that hires, let's see, 10 workers and it can produce 4, if it hires 11 workers, it can do 4.2. So we know that this 11th worker is 0.2, so 0.2. Let's write that down. 0.2 for this 11th worker, because marginally it changed by 0.2 when we hired this 11th worker. It sells each cabinet for 2,000 units and it pays $200 per day. So let's see which is true. So we could look at the marginal product of labor is how much you make how much this person makes marginally, which is not $500. So A is wrong. And then for the 11th worker, marginal revenue product is $400. Well, if it makes 0.2, I'll do it up here. So 0.2, and then it sells each cabinet for $2,000. So times 2,000 is going to be 400, and the unit is, I just wrote the integral sign, $400. So B seems pretty good. We don't know the firm is maximizing profit or not, so we can't say C is true. And we don't know if it would increase or decrease because we don't know if they have increasing marginal product or not. Or for this guy. Alright. Suppose that workers who sort outgoing mail use rubber bands. If there's increase in supply of rubber bands, which of the following would happen in the market for labor? So the market for labor is marginal revenue product. Again. And so if the price of these rubber bands, if there's an increase in supply of rubber bands, so if there's an increase in supply of the input to the workers, right? That makes them more productive. They're not waiting around for other people's rubber bands or whatever. So this instead would have marginal product go up in this case, making marginal revenue product increase. So this one is B as well. All right. So we have this table here. And so let's fill in the table. So we first have marginal product of labor, or marginal product. So at $0, things get kind of weird. So we're not really going to think about this, but the wage is $30 a day, so, but again, there aren't any workers, so it's not anything fancy. Alright, so let's look at this first one. So we changed by 1 worker, and we changed by 100. So the marginal product of labor is going to be the output, which is golf balls, divided by the change in the input, which is labor. So 100 divided by 1 is 100. And so here we changed from 100 to 250. Not 250, but 100 to 250. So it's going, and then the workers went from 1 to 2. So this is going to be 150, which is 250 minus 100. 150. All right. And then from 250 to 375, it's going to be 125. Let's see. 4. So we go from 375 to 475, so that's 100. And here we only go up 75. And then here we go up 50. So this is an output. So, and then we have value of the marginal product of labor. So we now just multiply. The value of the marginal product of labor is the marginal revenue product. It is price times the marginal product. So we can multiply each of these numbers by 50 cents, and we have our answer. So this is going to be $50. That's a dollar sign. 150, so that's going to be $75. 125 divided by 2 is 62.5. 62.5. Let's see here, 100, this is another 50. 75 over 2 is 37.5. And 50 is 25. And so the wage, I'm not going to write the dollar sign, but you know it says $30 a day. This is constant. All right, marginal profit. How much revenue we're making minus the cost marginally. So again, we're not doing the 0 days, but the cost is our wage and the marginal product of labor is our revenue, marginal revenue product, MRP. So this is going to be 20, and this is in dollars, but I'm not going to write the dollar sign here. So 75 minus 30, 35. Let's see here, 62.5 is 32.5. 32.5. That's 20. There's a point there, so that's 7.5. And this is negative 5. So now I filled in this table, we can start answering some of these questions. What is the third worker's marginal product of labor? Well, we can go to the third worker and go to the marginal product of labor, and that is 125. Let's see here. Marginal revenue product for the fifth worker, which is marginal revenue product, is just this. This is marginal revenue product. So the marginal revenue product is the value of the marginal product. So if we look at the fifth worker, we have 37.5. So 14 is also C. So where does the marginal product of labor begin to diminish? So over here we see this is kind of its peak and it begins diminishing here. So at this third worker, it's declining at that point. Because we don't know if it's declining at the second worker, and we see it's definitely increasing at between these points. So by this third worker, it's decreasing. All right, assuming it is competitive, is it in, or where would it be how many workers will the firm hire? So you want to hire up into the point where your profit is negative. You want to basically get as much stuff out there as possible. And so just because it is diminishing here, you should still keep going until you're literally losing profit. So you're not going to do 6 workers because you're going to be losing money. But at 5 workers, you will have the most amount of output. And so you want to hire up until the point where it's negative. So basically just before that. Okay. So what happens to the labor supply in a pear picking market where the wage paid to apple pickers increases? So when the wage for something else increases and they are similar things, right? Pear picking and apple picking are probably very similar jobs. Then these pear pickers will go join the apple picking market because they're going to make more money. So the supply in the pear picking market will decrease. Let's see. What happens to the labor supply curve in both these when Mexican workers leave and move to the United States. So, if there are people leaving the United States, their supply for labor, they are working less, is going to decrease. And if they're moving to the US, then there's going to be more people working, and so the supply of labor in the US is going to increase. So 18 is C. A difference in wages that reflects differences in non-pay features. So this is called a compensating differential. When you, for example, like a bus pass or whatever, is this thing called a compensating differential, and that's just vocabulary. It's not really a big skill. It's just kind of something you need, a term you need to know.